we go. There's Emma. In case anybody's looking for you. There you are this morning. Right, I'm not looking that. That looks good. Okay.
Kind of next week is my next week if you have the week off, it's kind of like you're taking your week off on my birthday.
Yeah, there you go. The week off for your birthday. It just works out that it happens to be the same week with Ash Wednesday in the middle of Valentine's Day. But also we're gonna be in Texas next weekend for a gymnastics meet. So
And RDOs has this Thursday off, so hashtag week off for my birthday.
Do you know Tori and Corbin? They're at RDOs, they're older, they're much older.
No,
But they live just around the corner.
are they high schoolers?
Yeah.
I'm only.
Yeah, didn't know if you ever crossed paths. Yeah, they're right around the corner from here, but they've been going there for years, so. Yep. So it's cool because when we go to Texas next weekend, we'll get to see Cole.
You get to see snow.
No, not where we're going. We're going to Fort Worth. There will be no snow.
Oh, yeah.
Yeah, we're going to Fort Worth, which is just south of Dallas, but kind of the same metro here.
Both of us got like the sand next to it, like all white.
Oh, isn't it pretty?
Yeah, it's like so cool. I took some
Beautiful.
sand home.
Did you?
Yeah.
It's beautiful there. I've never been there. I've just seen many pictures, but I've never been on that side of.
I've never been to the
water.
Alamo.
Yeah. I don't think so. What town is that in? San Antonio? Yeah, no, I haven't done that one. I did something in El Paso, but I don't remember what it was. It was years ago. My cousin got married in El Paso. Alexa, turn the gas log off. And we went to whatever was there. It wasn't the Alamo. It was cool though. They had like they had a lot of like the old prisons and like Billy the Kid was here for a night, that kind of thing. It was fun. It was really neat though. It's very it was pretty. I'm trying to see what it was now. I can't remember what it was I saw there. There's so awesome. Down here on 7th. That was a weird place. Yeah, we did see a mission. There was an old mission. That was neat. But it's a weird place because it's like it's right on the border, so you can stand in El Paso and look at Mexico. And unfortunately, the town that's right there is Juarez. And Juarez is not in good shape.
Like, what do you mean not in good shape?
It's very poor. The people are very poor. And like the biggest industry really is the drug trade. They bring illegal drugs across the border into the US. There's there's a couple bridges. And every morning there's this influx of people that walk from Mexico over the river, over the bridge, into El Paso, and then they spend their days working in like the hotel, the restaurants, and the retail stores and whatever in the US. And then about 5 o'clock, you see everybody leaving. Like this entire crowd of people walk the streets of El Paso and then they cross the bridge back into Mexico. But y'all, every time we looked into Mexico, something was on fire. Like Juarez was just on fire the whole time we were there. Like little shacks.
Kind of scary.
It was. And I thought, I don't blame any of these people for not wanting to go back. Like I know we have a huge immigration problem, but I understand why they don't want to go back over the bridge. Like I get it. I get why they would stay. But it's really bad because there's a big giant red X. It's like a statue. It's huge. A couple stories tall, kind of a thing. And it's out kind of in the middle of the river, and it's supposed to be there as a memorial for all the people who died as a result of the drug trade. Because there's so much crime around it, and people die. So they've got this giant X memorial that you can't, if you're anywhere near the river, you can't avoid it. It's just this huge, big thing. Like, here it is. This is what's going on here every day. It's like, geez, this is really depressing. Yeah, it was a very brown little town. It was not my favorite place I've ever visited. I don't think I'm gonna go back for any reason unless I have to. Like my
Unless you have
cousin's,
some.
yeah, for some good reason. My cousin's wife's from there, so that's why the wedding was there. But,
You have to go there.
yeah, so we went to the wedding, but it's funny, cause his older sister, my cousin's older sister, so my other cousin, we were out driving around and she's from Phoenix. And she says, okay, Phoenix is ugly and brown, but this town is even uglier and browner than Phoenix, and that's saying something. And I was like, okay, wow, tell me how you really feel. She was unimpressed, so. And she's a pretty outspoken person, so she'll just tell you what she thinks. But yeah, it's a sad little town. I feel bad for it. Juarez in particular, that's just very sad.
I feel
There
bad.
should be less population.
They don't have anywhere to go. They really don't. They have nowhere to go. And they have nothing to do. And people like, the cartels will like threaten people and make them carry drugs over the border for money. And
I saw this thing
Yeah.
on YouTube that there's this death road that it has no bridge and cars and like billions of cars have went past it and then they fell down.
oh, Lord,
Like there's no
like rail.
yeah, right.
Yeah, that's not good. Put a rail up. How hard is
That's
that?
called a death road.
Yeah, I don't wanna do that. You
Yeah,
need a rail.
I think it got banned because most of the cars that went there fell.
That's
And it's
crazy.
like 2,000 feet deep.
That's nuts. Yeah, that's nuts.
So I don't know who would go there.
Yeah, they were saying like the people that live there were telling us stuff about the town, but they were saying that the drug cartels will like. Say somebody works as like a housekeeper in one of the hotels right there, because there's a lot of that, like pretty much all of them come across the river every morning. And he said they'll make them carry the drugs across the border under threat of death or under threat of killing a family member, whatever, if they don't do it. So they turn these people into like federal criminals, right? They're just trying to make a living. And it's real scary. You can't say no to them. You don't have a choice. Like if they approach you and they're like, you're carrying this drug across the border today, you pretty much do it. You don't have it. Saying no is not an option. So it's just,
Terrible.
it is, it's awful. It's real awful. But hopefully one day it will stop. That's my hope, that one day we can quit the craziness, because it's just ridiculous. Very sad, very sad.
I guess it's kind of
Yeah. It is. So this one's fractals. Oops. Fractal designs on it. Okay, it's cool.
We are early.
Yeah, y'all are very early today.
Yeah.
Y'all are super early. Did your dad have a meeting or something?
No, he always drops us early.
Yeah, you were 30 minutes early today. That's very early.
We were about 30.
Sometimes I'm just barely getting dressed, from showing up. I gotta get ready for Jackie, so I mean, I make sure that I'm ready when she gets here, but some days I'm still upstairs when she comes to the door. I try to be, but sometimes I still am. You do anything fun this weekend, Emma?
You know, we're going up to Greenville on Thursday because we don't have art yet this summer. Right.
What you doing in Greenville?
Lauren.
Exploring? Okay, so do you know about the mice? Okay, so definitely tell your mom this is right up her alley, but there's like, I think it was an Eagle Scout project in Greenville. Do you remember, Jason, was it, the mice in Greenville, were they an Eagle Scout project?
Yeah.
Yeah, so they're these little bronze mice, little small bronze mice. Yeah, on the main street in downtown, and they're hidden along the storefronts and like the benches and stuff like that. And you're supposed to find them, I think, in order. I don't know, I'm sure if you Google it, you'll find it, but it is something your mom would totally do, and your little sisters would like eat it up. It would be right up their alley. So,
Fun.
yeah, Jack would like it too. I mean,
Gotta find them.
oh, did Jack get his license?
Yes, he got it.
He got it? Oh, really? I'm so excited. That's great.
I tried to get him to take me today, but he's not exactly an early person.
He's never been a morning person, but that's okay.
He needs a bit more warning before I
Yeah,
So maybe next week.
well, that's so cool. I'm so glad that he's got his license now. It's so nice. The freedom is nice. Like, I was scared to death the first time Cole left, but then after that, I was like, this is great. I don't have to take him where he needs to go. He can take himself. That's yeah. Yep. I'm nobody's chauffeur. Now I'm just Drew's chauffeur, which is okay because he'll have his license sometime this summer. That'll be great.
My brother's my person.
Yeah. But he's a good guy. He's a good guy to have as your personal chauffeur. He's fun. He's a good kid. Yeah. Drew's practice. I mean, he drives to and from, we have a carpool for gymnastics because our gymnastics is all the way in Marietta. So we have a different parent that drives, but he drives from here to where we meet for carpool every day. And then he drives from where we drop off for carpool home. But there've been a couple times when I've been at the gym and one of the other parents came up, so all the other kids would just pile into that mom's car so that Drew could drive all the way home from Marietta. So we've done that a couple times. And then last week, they've been closing the exit to get on 400 from 285. So that's the way we go home. And they close it around 9 o'clock. They're pushing it back a little later, it seems, the last couple days, which is good. But my friend got over in that lane and she got stuck. And they were stuck for a long time, like 30 minutes of time they lost just trying to get home. 40-minute drive. Like, it was pretty bad. It added 30 minutes to a 40-minute drive. But we went past it and went all the way down to 141. And so Drew came up a different way than he'd ever come before. So he's like, where do I turn to go home? I said, I'm not telling you. I'll wait until you recognize where you are. And then you can say, oh, I know where I am and how to get home from here. Like, I'm not going to tell you, figure it out. So it was very foreign to him. He had no idea where he was. Sooner or later, he was like, I know where this is. I know where this is. That's Target. I can get home from Target.
Danny?
Yeah.
Does Drew know how to drive a car?
Yeah, that's what I'm saying. He's been driving with this permit for a long time. Yeah.
Drew?
Yeah, since like June. He's got his permit in June, I think. Yeah.
How old is he?
He's 15. He'll be 16 in May.
I'm gonna be 13 tomorrow.
Tomorrow.
Be a teenager.
Goodness sakes, not another one. Not another one. Are you coming back next year?
Probably.
Are you doing this class or the next class? You doing the?
I don't know.
Yeah, no, your mom only had Jack in juniors for 1 year. That's why.
Bye.
Bye. Good luck. And then
I'll still be in junior.
you'll be in juniors next year. Yeah. I think about half of y'all have already re-enrolled, which is good. I don't remember. I have to go look and see. That's why I was asking you.
If I'm staying in juniors or going up to.
Yeah.
You know, I think some start doing juniors.
Mm-hmm.
My friends.
That's good. That'd be good. Yeah. We could use a couple more juniors. It's weird. It's like, at first I tried to have like a hard cutoff for each class, like a number, like no more than 12, but that doesn't really work because it's actually works. Like, I have a hard cutoff for full number. Like, I can't do more than 24 because I can't physically fit you at the counter. That's what it is. Like, we can do lab teams with as many as 6, but we can't do lab teams with more than 6 people because you can't get to the counter. So I can do that. So it doesn't matter then if I have like 4 of those 24 in juniors and 20 of them in lab rats, that's fine. But 24 is the code. Yeah.
6.
Yeah, because this year it's 6 and then 12. Because I have 22. So not 6, 12, 16, sorry. Because I have 22. Yeah, that's the biggest group I've ever had this year. 22 is big, real big.
You're gonna have 23, but then
Yeah, Landon, yeah, don't know what happened to him.
he broke his arm.
Yeah, but I mean, I don't know what happened after that. Don't know if he's okay or.
He's fine. I see his sister.
Oh, you do? So you know him? Mhm.
Yeah, I know. I go to Ardios with his sister.
Okay, he's already. Well, hopefully he shows up next year. That would be cool.
Yeah.
Yeah? Mm-hmm.
We're gonna learn about kind of like chemistry in Q4.
A little bit, yeah. We do start chemistry in Q4, which is cool because it leads nicely into next year. So when you show up next year, you're not at a total loss at the beginning of the year. You have a little background.
It didn't work out, so
like physics ends with a little bit of chemistry, which leads into chemistry, and then chemistry ends with a little bit of
Bio.
bio.
Yeah.
And then it leads into bio.
And then bio ends with a little bit of like earth related stuff, like ecology related stuff, and then that kind of moves into, well, actually, the way I don't really end bio as much with the ecology stuff. Some of that's at the beginning of the year. It just kind of works better that way. But we do, we really end bio with like, it's almost like a health unit. It's like a human anatomy unit and some kind of health related stuff. But do you remember when your brother did it? Like you get the big model, like the big piece of paper that's like a person's body and you get to stick the organs on it. It's super fun. Like I get like big butcher paper rolls and everybody lays down on a piece and they lay down and somebody traces your body on it. And then you get a booklet that you write in, and then you get a whole bunch of papers that they're the outlines of organs. And you have to cut them out and color them, and then you have to glue them on your model. It's really cool. And what was very funny was I had one kid that like he was real smart and real fast at everything. Always got everything right, but he put his stomach on completely upside down, and it was hilarious because I was trying to figure out what was wrong with his model when he turned it in. I'm like, why is this not fit? Oh, sense now. But it's cool. You get like one of your legs is muscles and another leg is bones, and it's really cool. So you get to make this like giant model of yourself. That's kind of fun. A body model. Where's my peeps? They're coming. Oh, hi, peeps. Yeah.
They have the traffic stuff.
Yeah, they
So,
do. It's gonna be.
construction work.
It's gonna
We
be rough.
started at 9 o'clock, so the traffic was not that.
Yeah, not too bad. Yeah.
We got lucky and it turned basically from stop to slow as soon as we got there.
Do you come across McGinnis Ferry or do you come across 20? Like, do you come past the big soccer fields and everything?
Yes.
Okay, so you come across McGinnis Ferry, yeah. Cause I think from your house, you could go either way.
Probably.
You
You're on the
come
other side.
across the Forest Academy School, the middle school.
She'd pass the elementary school from where she's coming. She wouldn't pass south. You would pass south.
Have you ever seen the water tower in Swanee?
Other side of the river.
Oh, the other way.
Yeah, on the other side of the river from here. Emma's on the other side of the river. And so are Darcy and Lewis, although they used to be right over here. 2 years ago, they moved, now they're over there. I don't know where Nico and Carlos are.
But if you've ever seen the water tower, I live on that property.
Yeah.
Except there's a square cut out of it that the water.
That the water tower sits in,
I
yes.
live near the Dave's Creek School.
Yeah, you live right over
It's
there.
kind of cool. I can just
I
my
can
house
walk
into
to
the
the
water
Dave's
tower.
Creek School.
Can you? Yeah.
It's gonna be weird when I move to this new house. I'm not gonna call it a water tower house.
What new house? Are
Oh.
you moving?
Eventually, at the end of the year, technically, I'm not really supposed to be speaking about it because we haven't like listed, which is kind of like
Yeah,
starting it.
yeah.
So, and we don't really have like a house picked out.
But you're
so-
staying in the area?
We're actually moving about an hour away, but I'm still gonna go to science and REOs.
Oh, that would be cool.
I wanted to get out of the.
You're homesteading, aren't you? Your mom's gonna do that. I knew it. Yeah. Well, my neighbors next door are moving. They said, don't say anything yet, because all the real estate agents in the neighborhood will be really aggressive, and they do. Like one of our good friends is a real estate agent in this
Does
neighborhood.
that neighbor have a pool in the back?
She does, yes, but that house, I think they're about to list it, unless she was trying to see if we could find anybody who wanted the house prior
I
to
would
them
definitely
listing.
buy that.
Yeah, she was like, we would love to not involve an agent, we'd love to have somebody who just wants to live in the neighborhood and the house will work and we could just do it without agents involved. I'm like, good luck with that, I'm getting an agent involved every time, there's too much legal mess. So, but that's what they were trying to do. But, so they had on, I guess it was Friday or Thursday of last week, I think it was. I woke up at like 7 AM because there were leaf blowers and weed whackers. They had people over there like trying to make their front yard is always perfect and their side yard, but their backyard, especially like beyond the pool fence, is always messy. So they had people out there doing that. And then they have a dumpster. I don't know if it's still there. They had a dumpster.
I'm not the last person to arrive.
So they've been cleaning out their basement and whatever. Morning, crew. Hello.
Hello.
Stars and Mr. Blues. Oh, there you are. You're over here. Yep. All right, let's roll. Everybody's here.
We're gonna have cupcakes now.
Oh, yes. It is Emma's birthday tomorrow, so she has brought us cupcakes. Thank you, Emma. You may distribute cupcakes.
It's my birthday in 11 days.
There you go. Outstanding.
Oh. My lab 20, I forgot it.
That's okay. Just pop it over there. We'll get it. Those are lovely. See, here, look. Help yourselves to chocolate. You know I'm taking one. I'm not gonna ignore that. Ooh, that's gooey frosting. That's the way to go. All right. Just be sure you, after class, you toss these napkins in the trash so that Ozzy doesn't try to eat the chocolate covered napkin, because that will not be good for him. And he will do it. He will see it and go, "Oh, yum." All right, crew, let's roll. So light and optics is today.
Are you gonna learn about glasses?
Woo-hoo. Actually, yeah, pretty cool. So first thing we're talking about is reflections and mirrors. Everybody either loves or hates a mirror, kind of depends on you. Yeah, no? All right, so when light strikes an object, the light can be reflected, absorbed, or transmitted. So obviously, these are our options. So what kinds of materials reflect or absorb light? What would you call those? What would you?
The one that light does not pass through is opaque.
That's right. Mm-hmm. So what transmits light then? Darcy? Transparent and also translucent. It just, yeah. So what kind of materials absorb or reflect all light? You said it?
Transparent.
No,
No, opaque.
opaque. There you go. Mm-hmm. No, most objects are opaque. This little rat is looking at an opaque wall. Can't see through the wall. You ever have an old person? It's gonna be an old person usually. Cause it's like, it's not even a dad joke. It's like a grandpa joke, but you'll be standing in front of the TV and they say, "Move. I know you're a pain, but you make a better door than a window." Never heard that? Yeah. My grandfather used to say that. "Oh, I know you're a pain." I'm like, "Oh, you're funny." So what kind allows some light to pass through? Yeah.
Translucent.
Mm-hmm. That's right. So frosted glass, stuff like that.
Screens of the.
Mm-hmm. They create like a translucent material.
Fabric.
Yeah. Uh-huh. That's right. Okay. So that'd be translucent. Like in this case, it's like a little frosted window. He's looking out, maybe some hammered glass or something like that. And does nobody notice the extra limb? Because I just saw that. Yes, that's
yeah.
that's an AI hallucination. That's fun. Don't know what happened to him.
got a double tail.
Yeah, he's special. Oh, did he? That's,
Cookie sand.
no, I think that's a foot.
Huh?
I don't know.
That's a foot. Yeah, that's a foot.
So what allow all light to get transmitted? We said transparent. Okay, obviously he's peering out the window now. So you can see most objects because light reflects or bounces off of them because most things are opaque, right? Just the way it is. So in studying light, you can represent it by drawing it as a straight line, usually with an arrow on one end. What do you call a line with an arrow on the end in math? What do you call it?
Right?
All right, you got it. Okay. So this kind of diagram is known as a ray diagram usually, or yeah, a ratio. Yeah. Now ray diagram. So you can see like this is a great example. So here comes the light, right? Bing. And you can see right here, like here's the mirror and it's getting reflected. You can see the arrow, so you can tell which way it's going, right? Anybody done any pre-algebra or whatever yet, where you start the little graph and you make the little line, the little arrow? There you go. Yep. All right, so a ray diagram shows how rays change direction when they strike mirrors or pass through lenses. And this has to do with the angle, and we'll talk about that in a minute. So when parallel rays hit a smooth surface and reflect in the same direction, what do we call that? What do we call it, Carlos?
Regular reflection.
Yeah, regular reflection. And sometimes you may see it called specular reflection. So I put that right here because sometimes that word will pop up and you might see it written as specular. So do you see how these are parallel? Where'd my little mouse go? Hello, mouse. Oh, here it is. Yeah. You see how these are parallel rays, even though they're coming in at an angle, they're parallel to each other, right? And then they're reflecting off parallel. So when parallel rays hit an uneven surface and reflect in different directions, Darcy?
Diffuse.
Yeah,
reflection.
diffuse reflection. So that's like, right, you can see these three are parallel coming in, but this is an uneven surface. So they're bouncing all around, kind of crazy. There you go. So what's the law of reflection? So first off, let's talk the angle of incidence. What is the angle of incidence? Does anybody know what that is? Anybody know? Do you know, Eunice? Do you know? He's looking. How about you, Darcy? Do you know?
I think it's to do with incandescent rays and how
Mhm.
they're parallel.
Yeah, it's really kind of in any kind of light. So basically, your angle of incidence is the angle that's created by the incident ray, which is the incoming light ray, okay? And a line drawn perpendicular to the surface of the mirror. So that means this. Which color is the line perpendicular to the surface of the mirror in that diagram?
Red.
That's right, red. Perpendicular mean not parallel, the opposite. Makes a nice, what kind of angle would you call this angle between, like,
120 degrees.
no, between the red and the mirror?
25.
25.
45, 45.
45.
No. Between here and the mirror, all the way down.
Oh,
That's a 90, right? Okay, so it's perpendicular because it's at a 90-degree angle. So then what you get for your angle of incidence is the space between where the ray comes in and you've imagined that perpendicular line. So this does look about 45. Yeah, you're right, about 45. So if that's the angle of incidence, then what's the angle of reflection going to be?
50.
Can you tell by looking at the diagram?
that way.
Yeah, go what way? Go the opposite way, basically. So your angle of reflection is created by the reflected ray. That would be this one, just going away, right? And a line drawn perpendicular to the surface of the mirror. So they tend to be the same if you have a nice regular reflection. If they have a nice regular reflection, then it's going to be 90 degrees. So look back real quick at this. So, well, not necessarily 90 degrees, but they're going to be the same, basically. You see how this ray coming in and this ray going out? If you imagine a line right here, do you see how that the angle of reflection and the angle of incidence would be even?
Yeah.
Whereas if you put it like over here, it's not going to be at all because it's going to be funky looking, right? All right. So now we have different types of images. Now this is funky. You got to kind of forget your normal understanding of English vocabulary and just imagine these words as meaning something totally new to you, okay?
Okay.
So we have real images and virtual images. Okay, fun. Real images, this is the easiest way to remember this. Real images can be projected, okay? You ever seen an old video projector? Like you shine a light through the film and it hits a wall, right? That's a real image. So they can be projected. They can be upside down. Very often they are upside down. So sometimes, like if you're trying to project something, it might actually be upside down on the projector. So when it hits the wall, it's right side up. Okay, that kind of thing. And smaller than the actual object and can be formed by convex lenses or mirrors. But virtual images, you can't project them. And they can be right side up. They can be bigger or smaller than the actual object, and they can be formed by concave lenses or mirrors and convex lenses or mirrors. So how can a convex lens or mirror make both a virtual and a real image? So I'm going to show you a video that shows you exactly how that happens in a minute. Okay. So what is a copy of an object? Here we go. All right, Carlos.
Image.
All right, yeah, so there's image, just basic image is a copy of an object produced by reflected or refracted rays. So mirrors produce images. What kind of a mirror is a flat mirror? What do we call those? You know, Eunice, do you know? No, flat one is going to be, do you know, Nico?
A plane.
A plane mirror. It's a plane, a flat plane, right? Okay, that's a plane mirror. All right, now. Click. There you go. A plane mirror produces an image that is right side up and the same size as the object being reflected. Right side up. Okay. Which one is it going to be then?
Virtual.
It's a virtual image. It's a virtual image because you can see it but it's not really there. It's just light reflecting back at your eyes, which is weird because mirrors seem pretty real and what you see in them seems pretty real, but what's in a mirror isn't actually there, right? What you're seeing is the light reflecting back at you and it's showing you what's actually around you, right? Kind of weird to think about. So, what kind of image was it? We just said it? Yeah, but what kind of virtual image, right? Okay. It's right side up. You can see it, but it doesn't really exist. So what is formed when rays meet at a point, Darcy?
Diverging lens?
Okay, well, yeah, kind of. We're going for here is a real image. Okay, so a virtual image is in a mirror. All right, you can see this, it's there, but it's not really there, right? You can see it, but it's not really there. So a real image is formed when rays meet at a point. They're upside down and maybe large or smaller than an actual object. This gets really confusing. Sometimes like, well, what are you talking about? So I'm gonna show you a couple of videos that really clear it up. So mirrors come in different shapes and sizes. Not all mirrors are plane mirrors. So what kind of a mirror is curved with the mirror reflecting surface on the inside? Nico?
Concave.
That's concave. That's right. And what do you call the point at which the light rays meet? What's that, Eunice? Do you know? No, that's a good, so that's a focal point, okay? That's where all the light rays meet. So what type of image is produced in a concave mirror? What do we think? So I'm looking at that. That looks like him, right? What do you think, Emma? She's thinking real? Who thinks real? Okay, who thinks virtual? Oh, it's interesting. We're about evenly split. So it's real or virtual. Okay, how is that? Oh, okay. I promise it'll clear it up in a minute because that's crazy.
Miss Danny.
Yeah.
I was at my friend's house
Mhm.
yesterday.
Mm-hmm.
She had this dish that with mirrors all inside of it.
Uh-huh.
And a hole, and if you put like a queen in or something.
Oh, look, I can float?
Floating.
Those are so cool. Yep. So what do you call a mirror that's curved outward then? Not curved inward, but outward. Carlos?
Convex.
Convex. Okay. So here's a convex mirror and it's got its reflecting surface on the outside. So in this case, this bumper right here. So over here, we have a spoon and this was acting as a concave mirror in this case, right? And here we have a bumper on a car and it's curved outward. So it's acting as a convex mirror. So what type of image are we getting in a convex mirror? Okay, Nico, what do you think? Virtual image?
I agree with that
You are right. Convex mirrors always cause light rays to spread out. Think about it, right? It hits this curved surface like this, so it's going to spread out when it comes back. So you only get virtual images. All right. Are we getting a little confused? This will hopefully help. This dude, he must be in Georgia somewhere because he uses what looks like a concrete UGA to me. I think it's UGA.
My friendly little bulldog, and we're going to show what happens to the image in a concave mirror. Notice right now it is enlarged and not inverted. As I move it towards the focal point, it will enlarge and it will be at the maximum size at the focal point. Now, as you move towards the center of curvature, look what happens to the image. It will begin to get smaller and it will also be inverted. Okay? So there's Mr. Bulldog, inverted and smaller, and as you go further away, it's going to be smaller. Now let's see this in reverse. It is inverted. At the focal point, you will notice that the image is at its maximum. It is enlarged. Okay, and then beyond the focal point, getting now is no longer inverted, and Mr. Bulldog sees a large image of himself. I think that's pretty cool. Concave mirror is because of the way the focal point is. Okay, let's take a look at an image in a convex mirror. They're able to show panoramic views. It's because of the way light is reflected and the focal point. Notice the headrest on the seat, and now let's compare that to a regular camera. I'm in my van and I can have two types of mirror. And here's the image in a regular van.
Like a plain mirror, right?
Headrest. You're only seeing the headrest on the left. And now let's go back to the convex. And you will notice that you can see the headrest on the left plus the other seats. A panoramic view. Convex. Regular mirror. Kind of cool.
Little mirror, man. Anybody have one of those mirrors in a van or a SUV?
Yeah.
We have one. They call it a conversation mirror. I don't think it's much for conversation. It's more like making sure your kids aren't ripping each other apart. Look back and see what they're doing.
That's exactly what it's.
Yep. So refraction and lenses. Okay.
How about
Who are my corrected vision humans? I see at least 3 of you that I know. You have contacts or you wear glasses when you read? Okay, so there are at least 4 of us in here.
I have both of them.
Yeah, both of those. Yeah. Okay.
Um,
So the 3 of you over here that don't have contacts or lenses, you're about to get schooled here a bit. Do you know your prescription?
yeah, I do.
You do? She's not sure. What's yours?
Mine is 2.75 in my left eye and 2.5 in my right
Minus in both
eye.
or plus?
Negative.
Okay. Yep. How about you?
I don't know.
No, so mine's like negative 4.75, negative 5.25.
I think,
Yeah, one these days.
Miss Danny, I think mine would be like around 4.
Okay. All right.
Mine
So
is like negative.
yours is negative 2. Okay. Uh-huh.
My friend has negative 12, negative 2.
Is he legally blind?
Yeah.
Yeah. Mm-hmm.
Yeah, and he's gonna wear glasses and contacts in the longest.
Yeah.
I'm gonna.
So
I.
when light enters a new medium at an angle, the change in speed causes the light rays to bend or change direction, right? This is refraction. This is like when you put that pencil in that glass of water or the straw in the glass of water, it looks bent, right? Because the light is moving at a certain speed and then it gets to the water and it slows down because that is more dense than the air. So bending or changing direction, it's called what? What's that called? I just said it. What is it?
Refraction.
Refraction is bending, right? Okay.
It's also a type
Split your cupcake in half and put
Oh, yeah, and put the lid on top. Yeah. Yeah, you did the cupcake sandwich.
change direction.
There's enough.
She's a birthday girl.
So, yes.
There's a typo here.
Oh, you found one?
It says speed causes them to bend or change direction.
Oh, it says or change twice. All right, good.
I
Glad
think
you
we
caught
get
it.
brownies now.
Yeah, you do get brownies today, actually. We do have brownies for you guys today. So you get cupcakes and brownies. All right, so we can describe, are y'all good? We can describe how much a material causes a ray to bend by its what? What do we call that? Do you know? So we call it its index of refraction, which is related to its density. So there's, water, glass, different materials are gonna have different density. So the higher a material's index of refraction, the more it bends the light. So white light is a combination of all colors of light. So when you put white light through, Nico?
Prism?
A prism, all the different wavelengths, right, are refracted at different angles, separating various colors. And longer wavelengths are going to bend less than shorter wavelengths. And that way, that's why visible light is always sorted into the same order. And it's a what?
Rainbow.
It makes a rainbow, right? But it's always in this order. Red, orange, yellow, green, blue, indigo, violet. It's always, and it has to do with the wavelengths. So here's a
that's
trick.
double rainbow. You can sort of see it.
Kinda, yep.
The rainbow looks wonky. It looks like there's another layer of blue
Kind of.
under the purple.
So if you can remember the colors of a rainbow and the way they move, that will help you with your electromagnetic spectrum and visible light. It'll help you remember that red is going to be on one end and violet is going to be on the other end. So if you remember ultraviolet, then you know that's going to be your higher frequency, longer wavelength, and then red is going to be your lower frequency, shorter wavelength, right? Uh-huh.
When the sun is coming right at my backyard and my dad waters the plants, and the rainbow appears in my dad's eyes.
Yep. Now, what shape is a rainbow?
It's half circle.
actually a full circle, but we can't see it on Earth. If you're in an airplane and you fly over a rainbow, you can see the whole circle.
Oh, I'm gonna do that today.
Yep, yep. I didn't even know that till my father-in-law mentioned it once because he's a pilot. And I was like, that makes sense. So light which refracts in such a way that it looks like a reflection often near the ground. What do we call that? Okay, Darcy,
A mirage.
that's a mirage. Anybody ever see the old Bugs Bunny cartoons where he's going to Albuquerque and he says a mirage?
That's-
Yeah, right? Yep. That's where you learn it. Yep.
Like when you're traveling in a car and above the concrete, it looks like there's a bunch of little waves.
Mm-hmm. Yep, it sure does. Looks like water sometimes.
On turf fields. 'cause
Does it do it on turf
hot.
fields? Yeah. Oh, because there's a little black rubber in there. It gets real hot. So what's an object that is made of transparent material that has one or two curved surfaces? Eunice, that's a lens. All right. So he's got a magnifying glass. So that's a lens, right? All right. Now we're going to talk about going to get into glasses here a little bit.
Right.
We're heading that direction.
Sprinkle melted on my paper.
What did?
A sprinkle melted.
Oh,
on my
that's funny.
paper.
Well, now it's colorful. So somebody describe what's a concave lens? Like Darcy, describe it.
A concave lens is curved inward like a bowl.
Curved
and
in.
it can do real images in virtual.
There you go. Okay, so a concave, yeah, very good. So a concave lens is curved inward at the center, so it's thicker on the edge and thinner in the center, right? And they can form only virtual images. So your concave lenses can only form virtual images. Now, your convex lens, what's that one, Eunice?
A convex lens is thicker at the center and thinner at the edges.
That's right, thicker at the center, thinner at the edges, and they can form real or virtual images. You're like, wait a minute, but I have these on my eyes. Am I not seeing anything real? We're gonna come back to this color wheel in a few minutes. Let's talk about light and seeing for a minute. So, vision. You see objects because of a series of steps that involve structures of your eye and your brain. Now, if there's a problem or a disconnect or a abnormality anywhere between the surface of your eye and your brain, you're going to have issues with vision. You can have eyeballs that are perfect and still be blind because there's problems with your brain or your optic nerve. And they call that cortical blindness. So it's different than like the eyeball being the issue. It's actually on the neurological side. So, anatomy of the eyeball. Eyeballs are fun. So the inner surface of the eye is called the what? Darcy?
Hold on. 1 second. Oh my gosh.
See?
The retina.
That's your retina. Okay, so that would be this whole deal right here. Now, I want you to notice right here, see this little line that says fovea centralis, this little spot right here? This is actually where all your light is getting focused at the back of your eyeball. It's called the fovea. So your light hits the back of your retina, but like your focal point there is your fovea. And there's a disorder called macular degeneration. Anybody ever heard of that? So there's two types of it. But basically it causes, the more common one, they call it wet age-related macular degeneration. So you may hear wet AMD, but it's wet because it's actually due to bleeding. All the little blood vessels that surround that part of your retina where your fovea is, they kind of burst and your eye is filled with fluid. Okay. It's called aqueous humor, but it's a fluid and they will bleed into your eye. So now you've got blood in your eye, which makes it hard to see, but also all that part on the back of your retina is now damaged because all those blood vessels broke and now you've got scar tissue there. And what it causes is a big blind spot in the center of your vision. So you maintain some peripheral, but you can't see anything in front. And the scary thing about that is it's like, it can be an overnight thing. That happened to my grandfather. He went to bed one night, he woke up one morning and he could no longer see out straight ahead, just like that. And you could look at him in the light and you could see the blood like in his eye, like floating. It was weird. But yeah, it happens real fast.
There's a sport called Formula One.
A what?
Formula One.
Yeah.
They have this thing that protects them,
Mm-hmm.
and to hold it on, they have a thing right there.
Yep.
Kind of like holding a pencil here. If
Mm-hmm.
you focused over there, you can barely see it.
Yeah.
So they use that to their advantage.
Mm-hmm.
So it's even stronger in case of like this debris comes off.
Yeah, that makes sense. That's right. That's very smart.
This is obsessed with Formula One.
A third.
Dude, It's good. I'm all for driving.
Hey, he's a little boy. He needs.
So, yeah, he does.
Strong.
So we have retina. Okay, so what's the opening that allows light into your eyes? That's right here, a letter C. Darcy?
Pupil.
That's your pupil. We all know what that is, right? What color is your pupil if you look at your eye? It's black. That's right. Pupil usually black, black, black. And that's because you're looking into basically, it's like a hole. It's like if you were to look through a keyhole into a closet that was closed, no windows, a closet, it would be black in there, right? That's what you're seeing. It's the darkness inside your eye.
I just knows you.
What's the colored part of your eye called? Oh, Darcy.
Iris.
That's the iris. Okay. Now, this is interesting. If you have really light eyes, like I have very light blue eyes, they're very light. It can actually be really uncomfortable to be out in the bright light.
Oh, it hurts. It like burns.
Yeah, you need sunglasses even more if you have lighter colored irises. And that has to do with how much light is bouncing off your eye versus being absorbed into your eye. So like people with brown eyes, sunglasses are always smart to protect your eyes. But if you have light colored eyes, you need them even more. Yep. Yep. So what is the transparent outer coating? This whole thing all over the outside of your eye. What's that, Emma?
The lens.
Not the lens. Outside. You're close to outside. The whole outside, you know? Oh, Nico knows. He's very excited. That's the cornea. Okay, this is the thing you can scratch. Anybody ever had a scratch on their cornea? That's
My
terrible.
friend did. She got a bit of metal stuck in her eye.
I scratched mine when I first got contacts because I ended up being allergic to the solution and it was like really itchy and really bad. And I was trying to get my contact out and then I scratched my cornea. But the way they check for it is actually really cool. So they use this thing called a Woods light, which is basically just a UV light. But they use this dye, it's a fluorescent dye, and they drip the dye in your eyeballs, and your eyeballs now under the black light, they're like Eunice's shoes, like the laces on Eunice's shoes. And then it's fun because there's connections between the cavities where your eyes and your nose are. So when you blow your nose, yep.
Like in the middle of the night. If you
That's
hold
what
your
comes
nose
out.
in your hand.
Yep.
Oh.
So what is this sealed fluid-filled capsule? All right, this one, Emma.
This one's the lens.
This one's lens. Okay. So your lens is actually, it's actually hard. Like if you feel it, it's hard. It feels like a piece of hard plastic. There is fluid in it, but it's very rigid. All right. Now, lastly, we've got two different types of cells in our eyes here. We have those that function mainly to sense different levels of light and those that are sensitive to color. So which ones do the light, Eunice?
Rods.
That's right. You got rods for light. And then which ones, Emma?
Cones.
Everybody got it. Yeah. Okay. Cones. All right. Rods and cones. And I want you to look. What color are the cones?
Red.
Red and green.
Red, green, and
Purple.
blue, basically. What did we learn about colors of light?
Oh, the pigments, the three primary pigments are red, green, and blue.
Red, yellow, and blue
No,
are pigments.
Red, yellow, and blue are
Light
pigments.
is.
Light is red, green.
So what color are our cones? We have those that sense blue, green,
Red,
and
green.
red. We had this in our eyeballs before we put it into pixels on our screens. Look at that. Basically, you got like a giant eyeball up there. All right. Correcting vision. Okay, here we are for all of us with our eyeball problems. So normal vision, so the three of you with nothing on your eyeballs, you have what's called emetropia. You have normal vision. Congratulations. It may last, it may not last. You'll see. I didn't get glasses till I was 15. Then it started, then it was a downhill spiral from there. Yeah, nope. I made it till when I started driving and I realized that like signs were hard to read, especially like at night. And then the blackboard in school got harder and harder to read. And I was like, okay.
I can't even read any of the words.
So who's nearsighted? You said minus.
Hey,
So I am nearsighted. Nearsighted means what? What's it mean to be?
Can't see far.
You can't see far.
Yeah, your sighted is near. You can see what's near, not what's far, right? So if you took your glasses off, could you see far away?
I can see this paper
You're,
or that.
oh, do you have astigmatism? We're getting there.
No, I just like I said, I've had glasses since I
Mm.
was 5. I'm like an 8 or an 8.
Yeah. So I love this guy's jacket, by the way. It's very cool. Okay, so farsightedness is then going to be the opposite. So this means close object. So
My dad.
they're sort of opposite. The words are sort of opposite what you think. Nearsighted doesn't mean your problem is with near. It means Near is where your sightedness is. Yeah, I can see, I'm sighted only near.
I see.
Far-sighted means I'm sighted far. Now, my husband's far-sighted. He can take his glasses off and like, he can read something. He has trouble because he has astigmatism, but he can still see it. If I take my contacts out, I can't, my toes are all one big blob. Like I have to have something like right about here and then I'm doing this, you know? So astigmatism is a little different. So astigmatism is any distance things are out of focus. They're just kind of out of focus everywhere. But here's what it is. If you look, nearsightedness, which is called myopia, you see that you see the shape of this lens, how it's sort of long. Okay, kind of long. Look at it for farsighted. It's not long, is it? It's kind of too short. It's not round. And with astigmatism, it's an uneven thing. The surface of your lens is kind of uneven, and that's what causes things kind of anywhere to be out of focus. So it's a little harder. Now, my husband's contacts, this is cool. His contacts are called multifocal. And so they're like bifocals, but they're on his contacts and they're weighted so that they turn and they always float exactly right, so that the shape of his lens is corrected by the contact. It's very cool, but they have to be like custom made for him. So they're not cheap, but he's very picky about his vision. So this is going to show you exactly how it works. All right.
Family, all my aunts, my uncles, my mom, and my
Yeah, you're all glasses people.
They all have glasses.
I've got one of my friends who had like step glasses.
Welcome to Moving Math and Science and a demo on how glasses work. As light passes through the lens of the eyes, it focuses on the retina and allows you to see a nice, clear, sharp image. However, sometimes people's lens may be too curved or is too large and light doesn't focus properly on the retina. Farsightedness, or hyperopia, hyper meaning beyond, means that people can see objects far away, but objects close are blurry because the light is focused beyond the retina. Nearsightedness, or myopia, people can see objects, but objects far away are blurry because the light is focused in front of the retina. You can go to an eye exam and they'll recommend certain lenses. For farsightedness, it can be fixed with a convex lens. And with a nearsightedness, it can be fixed with a concave lens. Let's find out why.
Let's take a look at how farsightedness can be corrected. First, as light passes through the lens, when you're farsighted, you can notice that the focal point here is beyond the retina. So as a result, objects far away will be in focus, but objects nearby will seem blurry. You can correct this by using a lens, and you will use a convex lens. You can see the difference between the two lenses here. And here's a little trick how I remember. The edges of a convex lens are further or far apart compared to the edges of a concave lens. So I'm going to use this convex lens, and you can see when you place it here, it corrects the focal point, and now the focal point is sitting right on the retina, and as a result, objects far away can be seen clearly, and objects nearby can also be seen clearly. For sightedness, you have the opposite. You can see that the light is focused in front of the retina. When you are nearsighted, you can see objects that are near but struggle with objects that are far. You can use a concave lens. Now, when you focus it, you will notice that now the light is focused right on the retina. Okay, so here it is without the lens, and then here it is focused with the lens. So the near and the middle lens, the concave lens, corrects the nearsightedness. So in summary, a convex lens is used to correct farsightedness, and a concave lens is used to correct nearsightedness. Thanks for watching.
You might actually hear people use the term myopic sort of as almost like a literary device. And it'll be like, for example, somebody has a plan, but maybe the plan is kind of short-sighted, and they'll say that's very myopic. And that's what it means. Like, you're not thinking down the road, you're thinking about tomorrow. All right, so I'm watching the time. I gotta kind of move along a little bit. So using light for a minute. Okay, did you want to add something real quick?
Just how to, so I guess it's not that important, but I just had to realize why people think people's glasses are like nerds. It's because when you read a lot or like
Yeah, that's
you
right.
read a
Yep.
lot,
Uh-huh.
Your vision gets messed up.
Yeah.
Mm-hmm.
So people that read a lot
Yep.
don't need glasses.
Especially back when we didn't have good light inside. Yeah, when we read by candlelight. Yeah.
That's why people call them nerds because they
Mhm.
read a lot, so they needed glasses. Everything
Yep.
makes sense now.
So what's an instrument that uses lenses and mirrors to collect? All right, Nico.
Telescope.
That's a telescope. All right, so that uses lenses and mirrors to collect and focus light. The larger lens is called what?
Objective
That's objective. And what's the other one?
convex lens.
Or an eyepiece is the one closest to you. This is the same with the microscope. You have an objective and then the eyepiece is closest to you. I'm going to go through these real quick because I'm watching time for a minute and I have something fun to do. So I want to at least have a few minutes for it. Okay, reflecting telescope is going to use mirrors and convex lenses to focus light. And then there are refracting telescopes, and these just use lenses. So if it's reflecting, there's mirrors involved. That's easy to remember, right? Reflecting, mirrors. Okay, microscope is like a telescope, but instead of looking at far away things, it looks at small things that are near, right? And it uses a compound microscope, which is what we use for the most part. It's going to use two different convex lenses to magnify small objects. So one of them is your objective, and that's these guys down here. And then up by your eye is the eyepiece. And most compound microscopes, at least the kind that we will use in class, they have this little spinny thing at the bottom with multiple different objective lenses. So you can magnify more and more and more as you switch from different lenses. Cameras. Okay, we have different cameras here. We have camera is an optical instrument that records an image of an object. They're different kinds. Pinhole cameras, modern film cameras, digital cameras. How does light form an image? I'm going to keep rolling for a minute. So light rays are going to enter camera through an opening, and they're focused by a lens, and they form an image that's recorded on film. These are old cameras, not new ones. New ones are digital, and it's totally different. But this is how film cameras work. Like back in the day when you had to put film in a camera. And the crazy thing is now, you take a picture with your phone, you're like, oh, that's a bad picture, and you delete it. No. We used to go to events with a roll, and a good roll of film was 35. You could take 35 photos with one roll. You took your 35 photos, and then you had to go send them somewhere to get developed. And then you had to come back and get your pictures, only to find out that half of them were terrible and they weren't worth keeping. That's the way it went. So, yeah. Yep. So lasers. Laser beam consists of waves that have the same wavelength or color. So what's the word we're looking for, Darcy?
Laser.
Laser. Did you guys know that laser actually is it's like an acronym, right? It's light amplification by stimulated emission of radiation. It's an actual thing. It's not a word in and of itself. It's a word made of other words. So lasers have many applications. CDs, DVDs. Yeah, kind of. Yeah, radar's the same way. Medical stuff like laser surgery, dermatology, ophthalmology, fiber optic communication. You're in this house because of fiber optic communication. That's what Jason does. He does fiber optic telecom. So fiber optic, they're little like hair strand size glass, like tubes, but they're like the width of a hair. And they send light down them with lasers, and that's communication. So lasers also produce what? Holograms. You've seen those before, right? Photographs that look three-dimensional. These are fiber optics. Here we go. This is what I'm talking about. So they're long, thin strands of glass or plastic that can carry light for long distances. Fiber optics used in telecommunication, rapidly transport. What kind of code is it if it's in ones and zeros? Nico? Morse code, not Morse code.
Binary.
Binary. Okay, binary is 1010. Basically, what that means is light is 1, no light is 0. So it's like a strobe flashing of light. 1 0 1 0 1 0 1 1 1 1 1 1, right? So basically it's light or no light. And they send, do you know, you ever seen a construction site or even on the side of the road when they're working? Sometimes there's little flags on the ground that mark some kind of something underground. Yeah. So you know what? The blue flags tell you there's a water line there. The red flags tell you there's an electrical line that's buried.
And the orange flags are natural gas.
Nope, yellow's gas,
Yellow gas.
orange is fiber. So anywhere you see orange, that's fiber. All right, critical angle. I'm gonna roll through these because I do want you to do the fun thing. Critical angle is an angle of incidence that produces an angle of reflection of 90 degrees. What the heck does that mean? Well, it means you get total internal reflection. And that looks, I'm gonna leave these for you to watch later because I want to get to the fun part. But basically, it's when the ray comes back on itself. So whatever you're looking at, like in this case, there's a light being shined at one end, it causes the whole thing to light up. That's because you're getting it in total internal reflection. And I'll leave this one for you too. So I wanted to do a couple little color things with you guys because you didn't get to do this last week and the other group did. So the color of any object depends on what the object is made of and the color of light that strikes it. We learned that last week, right? When you filter the light, it changes the way something appears. So primary colors are three specific colors that can be combined in varying amounts and create all possible colors. So primary colors of light are red, green, blue. And then you've got secondaries, which are like magenta, yellow, and cyan. And then you've got complementary, which are two that combine to form white. And then the pigments, we talked about these. These are cyan, yellow, and magenta are your primary colors of pigment. So this is basically your red, yellow, blue. If you look at a printer, it's going to say CMYK are your colors. Cyan,
Black.
magenta, yellow,
Oh, we can see
black.
the colors on the cartridge.
Yes, CMYK, that's what that is. Cyan, yellow, magenta. The K is for black. And those are your primary colors of pigments. Complementary colors of pigments are two that combine to make black. I'm going to skip this one, but I want you to watch this one if you don't watch any of the others, okay? And this one here, down here, these are all linked in your email, right? Where I have your resources. Those are cool for color, but I want you to play a little game for, we only have like 2-3 minutes, but we'll do a couple of these. So on each slide, you're going to see 3 sets of triangles on the top and then 1 single triangle at the bottom. And it's your job to try and guess which 2 of the triangles are going to combine to make the one on the bottom. So
Oh,
is it set 1, set 2, or set 3 that combines to make the guy on the bottom? So I'll give you a second. Y'all think 1? 1. You're good. Okay.
Set
Three.
Set 3.
said 3.
3. You're doing good. Okay.
2.
2.
No, it's 3.
Oh, 3.
Don't get fast, I don't remember.
2.
You think 2? There you go. All right. Good for 2. Ooh,
3.
this one's hard.
3.
1. Nobody picked 1. Okay.
1,
1, 2, 1, 2, 1. Okay.
1.
1.
No, 2.
Yes,
1.
1.
I said
You guys are pretty good.
wait,
Two,
what?
two, two.
Okay. You're doing all right.
I can't.
3. Okay. You guys are good. You're doing better than the other guys did.
3.
1.
Ooh, we have a toss up. It's 3.
Yeah. Blue and yellow make green.
Ooh.
That would be 3.
I
That's
think
3.
yeah, that
That's
would be
3.
Ooh, I love it. 2. How about this guy?
I'm gonna say that's 3. That's 3 because it's got a blue.
That one's 3. There you go. Okay, now we watched some of these other videos last week on color vision,
No.
right? So,
I can see a blob. of
and
light.
this one I don't think we got to with you guys, but if this class is how you realize you're colorblind, I'm sorry, but
71. Okay. No. 27, 71, 8, 42. I can't see that last one.
this one's hard. That one's 18. They're real hard. So, okay. So today, on your way out, couple things. So you guys earned brownie points. So on your way out after lab, the brownies are up there by the goggles, by the eye protection. Take your brownie on your way out since you had cupcakes during class. Now, On your way out, grab a Valentine lollipop there by the front door. Emma's grabbing cardboard. Don't forget cardboard. Also, if you guys would only use those little white, tiny little paper cups that are on top of the candy machine, those little kind of guys to take your candy out rather than opening up the chest and getting out the bigger cups, that would be great. Because those bigger cups are supposed to be for like when we have a party or something to drink. And they're much more expensive. If we use them all up, we're going to run out of budget. You guys will be like sticking your head under the faucet because what can I do for you? No class next week, right? It's winter break.
What?
Yep. Yep.
No, I get
No class next week.
I get the week off. I get a long weekend, not a week.
Yep.
No, we got Thursday, Friday, Saturday, Sunday.
All right.
Monday.
And Monday.
All right, crowd, you want to round up?
Not crowd.